Hi, it's Double O Pi, your undercover chemist here. Today we're going to talk about conversions between concentration units. In order to follow this video, you're going to have to understand the definitions of the concentration units: mass percent, also called weight per weight, molarity, molality, and mole fraction. If you don't understand these, go back and review them in your book before you watch this video. We are talking about a lot of different kinds of problems in this video, and what I'm presenting here is a general problem-solving strategy that you will see me use on very, very different sorts of problems. First of all, identify which measure of concentration you need to calculate. That's usually a simple matter of just reading the problem. Next, use the definition for that measure of concentration to figure out what it is you need to know. When you have a list of all the things that you need to know, you can create a plan to determine each one of those things, and you'll go through all those steps. Once you have all that information in hand, you can then calculate your measure of concentration. So the problem with using a general problem-solving strategy is it's really hard to explain it just talking about it because it is so generic. So what I'm going to do is I'm going to use it to solve different sorts of problems, and you can see how I go through the same steps every single time. Okay, here's our first problem, which is talking about a solution of sodium hydroxide. Remember that our first step of our general problem-solving strategy is to figure out what it is that we need to know. So you read this problem and you identify that what we're looking for is the molarity of the solution. Now, step 2, we're going to take the idea of molarity and think about its definition. The definition of molarity is the number of moles of solute divided by the liters of the solution. Okay, so what do we need to know? We need to know two things: the number of moles of solute and the number of liters of solution. That's what we need to calculate. So let's now develop an actual plan for solving this problem where we calculate both the moles of solute and the liters of solution and use that to then go ahead and calculate molarity. So the first thing that we're going to do is calculate the moles of solute. In order to do this, we frequently have to make an assumption. And the assumption that we use is going to be assuming 100. Now, there are a couple of different ways you can do this. You can assume 100 grams, or you can assume 100 milliliters. Either way will work. I'm going to choose to use 100 grams this time, and you'll see why when we actually go ahead and calculate the mass of NaOH in the first step. We are going to use the mass of NaOH that we calculate in step 1, along with the molar mass of sodium hydroxide, to calculate the moles of sodium hydroxide. So that will give us the first thing that we want to calculate. Now, the second thing we want to calculate, remember, is the volume of the solution in liters. So we're going to take the mass of the solution and the density that we're given to calculate the total volume of the solution. So that will give us the volume of the solution in liters. And then we will have both of the things that we're looking for, and we're going to take that information and use it to calculate molarity. Okay, so here is our first step, along with the problem. So remember, the first step we came up with in our plan was to assume that we have 100 grams of solution. So we're going to use that assumption to calculate the mass of NaOH in 100 grams of solution. How do we do that? Well, we have a 50% by mass solution of NaOH. That tells us that of that 100 grams, 50% of the total mass is sodium hydroxide. That's what mass percent tells us. So we have 50%, or 0.5, of the solution, the total mass of the solution, or 100 grams, is the mass of NaOH. So of that 100 grams, 50 grams is NaOH. Now, we're going to use our molar mass to calculate the number of moles of NaOH. We have 50 grams of NaOH, and we're going to use the molar mass as a conversion factor to convert that into moles. Now, you can go through with your periodic table and add up the masses of sodium, oxygen, and hydrogen, and what you get is 40.01 grams. So you put that into your conversion factor, and you calculate that we have 1.25 moles of sodium hydroxide. Now, you'll notice that I put that information down in the blue bar at the bottom, 1.25 moles of sodium hydroxide, because we're not going to use it again until we get to the end, but we still need to know that number. Now we're going to do step 3, in which we use the mass of the solution and the density of the solution to calculate the total volume. Now the mass of the solution, again, at the beginning, we assumed it was 100 grams. And we need to convert that into a volume, and we use the density as that conversion factor. So for every milliliter of solution, we have 1.529 grams. So 100 grams of solution is 65.4 milliliters. Now, if you remember, the calculation for molarity wants volume in liters, so we've got to convert milliliters to liters and use the conversion factor of 1 liter for 1,000 milliliters, and that gives us 0.0654 liters of solution. So that's the second thing we were looking for. So again, that's going down in the blue bar down here. Okay, now we get to our last step. We're going to take the things that we calculated, and we're going to use them to calculate the molarity. Again, the definition of molarity is the number of moles of solute divided by the number of liters of solution. So we take our numbers, we plug them into that equation, and we come up with 19.1 molar solution of NaOH. Now, if you look at that, you see we abbreviate molarity with capital M. Make sure it is capital, because as you will see, we use small m for something else. Okay, so we've taken a generic problem-solving strategy and applied it to a particular problem. Let's now do a very different sort of problem and apply the exact same strategy. Here's the problem. It tells us the masses of potassium iodide and water that we use to make our solution, and it tells us the density of our solution. Now, what are we supposed to find out here? Remember, step 1 is always to look at the problem carefully and figure out what it is you need to calculate. So here we have two things. First of all, what's the molality of the solution? Molality is defined as moles of solute divided by the kilograms of solvent. We're also asked to find the molarity, which, as you remember from the last problem, is moles of solute divided by liters of solution. Now, very important, if you look at these two quantities, you'll see that although they both involve the number of moles of solute, you're dividing by two different things. In molality, you're dividing by a mass, and it is only the mass of the solvent, not the mass of the whole solution. With molarity, you're dividing by the volume in liters of the whole solution, not just the solvent, but the whole solution. So what do we need to determine? We need to calculate, first, the moles of solute. That's going to be used for both molality and molarity calculations. Second, the mass of the solvent in kilograms. We use that for molality. And third, for the molarity, we need to calculate the volume of the solution in liters. So once again, here's our plan. We have to calculate the moles of the solute first. And we're going to do that using the grams of potassium iodide, so the mass. We're going to convert that to moles. And then we're going to calculate the kilograms of solvent from the number of grams of solvent In this case, the solvent is water. Now the third thing on our list is to calculate the volume of the solution. Remember, that's the total solution. Now, how are we going to do that? We are only given masses, and we need to convert mass to volume. Anytime you convert mass to volume, you're going to use density. So we're going to take the total mass of the solution, because we want to find the total volume of the solution. We're going to use the density of the solution to calculate the volume in liters. Then we will have the three things that we need to do our calculations, and we can use those to calculate both molality and molarity. Okay, so here's step one of our plan. We're actually going to go through and do the calculations now. Use the mass of the Ki in grams to calculate moles of Ki. So we know that there are 428.4 grams of potassium iodide. And so what we need to do is convert that to moles. Anytime you convert from grams to moles, you're going to use the molar mass. So you look up the mass of potassium and you look up the mass of iodide, add those together to get the molar mass. And here's our conversion factor, 428.4 grams of Ki with our conversion factor, that is the molar mass. That tells us that we have 2.58 moles of Ki. Again, this is something that we're going to use later, so we're going to store it down here at the bottom of the screen on our green bar here. Let's go on to the next step. The next thing that we needed to calculate was the mass of the solvent in kilograms. Now, they've actually given us the mass of the solvent in grams, so that's very convenient, because all we have to do is convert grams to kilograms, and that's a very simple calculation. Again, we're going to use the conversion factor, where 1 kilogram of water is 1,000 grams of water. So that tells us that we have 0.306 kilograms of water. Again, storing that down on the green bar for later. Now we come to step 3. We're going to calculate the total mass of the solution, because we want the total volume of solution. So the total mass of the solution is going to be the mass of your solute, potassium iodide, plus the mass of your solvent, water, added together. That gives us 734.4 grams of solution. Now let's take that total mass and convert it to volume using density as our conversion factor. Remember, anytime you have to convert mass to volume or volume to mass, you're going to use the density. So here's our total mass multiplied by the conversion factor, where every milliliter weighs 1.46 grams. Now we could stop right there, and that would give us the total volume of the solution in milliliters, but we don't want to stop there because we need the total volume in liters. So we're going to add in our conversion factor of liters to milliliters, and that tells us that we have 0.503 liters of solution. So now we have everything that we need, and we're going to calculate molality and molarity. So let's do molality first. Molality is number of moles of solute divided by kilograms of solvent. We have those are the first two numbers down at the bottom. So we have 2.50 moles. So we have 2.58 moles of potassium iodide divided by 0.306 kilograms of water. And that gives us an 8.43 molal solution. So again, you see that for molality, we use the small m to indicate that this is molal and not molar. Okay, let's do molarity. Molarity, again, is moles of solute divided by liters of solution. So again, we use the same value for the moles of potassium iodide. We divide by our solvent volume, which is 0.503 liters. So that gives us a concentration of 5.13 molar. And again, molarity is indicated with a capital M. So we've used the same problem-solving scheme to solve a completely different sort of problem. Let's take it a little further and do yet another sort of problem in which we calculate different things. Here we're dealing with an aqueous solution of sulfuric acid. We're given the density and the molarity. And what are they asking us to find? Again, that's always step one. Well, we're looking for the molality which we already know from before is the moles of solute divided by kilograms of solvent. Here they also want us to find the mole fraction of sulfuric acid. So the mole fraction, when you're calculating, is always the number of moles of whatever you're calculating the mole fraction for. Here it's the mole fraction of the solute, sulfuric acid, divided by the total number of moles in the solution. So what do we need to find out? We need to find out what are the number of moles of sulfuric acid. We're going to use those in both calculations. We need to find out how many kilograms of solvent we have. Here our solvent is not explicitly listed, but it says it's aqueous sulfuric acid, so it's going to be water, because aqueous solutions are always in water. And then for the mole fraction, instead of dividing by a mass of the solvent, we're going to divide by the total number of moles in solution. That is, the number of moles of solute plus the number of moles of solvent. So we need to know the number of moles of solvent, the number of moles of water. Those are the three things we're looking for. Once we know those three things, we can make a plan. Here's our plan. Once again, we're going to start by assuming that we have 100. Here, it's a little easier to use 100 milliliters, I think. You can do it with 100 grams, and you'll end up with a slightly different plan, but you'll end up with the same overall answers. We're going to start by using the density to calculate the mass of the solution, and we'll see why we do that later. Next, we use the molarity to calculate the number of moles of sulfuric acid. So that's the first thing that we're looking for. So that gets that out of the way. The next thing that we're looking for is the mass of water. Now, we don't know the mass of water, but we do know the total mass of the solution. And we can calculate the mass of sulfuric acid from the number of moles of sulfuric acid. So the mass of water is going to be whatever's left after you subtract the mass of sulfuric acid. So that will give us our mass of water. Then we can use the mass of water to find the number of moles of water. Again, anytime you convert from mass to moles, you're going to use the molar mass. So that will give us our moles of water. There are the three things that we're trying to calculate. We can then use those to calculate the molality and the mole fraction. So here's our problem with our first step. So we're going to assume that we have 100 milliliters of solution and use the density to calculate the total mass of the solution. Take 100 milliliters, multiply by the conversion factor of 1.70 grams for every milliliter, and that gives us 170 grams of solution. Now we're going to use the molarity to calculate the moles of sulfuric acid. Now, molarity is moles per liter. We have 13.5 moles in every liter. Do we have 1 liter of solution? No, we don't. We have 100 milliliters, which we can convert to liters. If you can do that in your head, it's 1/10 of a liter. And then once we have the volume in liters, we can multiply by our conversion factor of molarity, which converts liters to moles, or vice versa. And we calculate that we have 1.35 moles of sulfuric acid. Okay, so now we know the moles of sulfuric acid, and now we want to calculate the kilograms of solvent, the mass of water in kilograms. This is a two-step process. We know the total mass of solution, and we know that of that 170 grams, part of it is sulfuric acid, and the rest of it is water. We don't know how much water we have right now, but we do know how many moles of sulfuric acid we have. So let's convert our moles of sulfuric acid to grams of water. Again, anytime you convert moles to grams, you're going to use the molar mass as your conversion factor. So you have 1.35 moles of sulfuric acid. That's what we calculated in the last step. You can use your periodic table to calculate the molar mass of sulfuric acid. That gives you 98.09 grams. And when you calculate that out, you find that we have 132.4 grams of sulfuric acid. we don't need to know the grams of sulfuric acid. We need to know how many grams of water do we have, or how many kilograms. Well, if we subtract the mass of sulfuric acid from the total mass of the solution, we find that we have 37.6 grams of water. So the last thing that we need to calculate is the number of moles of water. So we know we have 37.6 grams of water. We can use the molar mass of water to calculate how many moles of water that we have. So we can use the mass of water that we solved for in the last step to calculate, using the molar mass, how many moles of water we have, and we find the answer is 2.09 moles of water. Let's take that information down in the bottom of the screen and use it to calculate the molality and the mole fraction of concentrated sulfuric acid. Molality, if you remember correctly, is moles of solute divided by kilograms of solvent. So you can see down in the bottom, our solute is sulfuric acid. So we're going to have 1.35 moles of sulfuric acid divided by the kilograms of solvent. Now, we put our mass in grams. That was kind of useful when we were converting it to moles. You would actually need to do a separate conversion to convert it to kilograms, which I didn't do in this video. But you can see that it converts to 0.0376 kilograms, and that gives us a 35.9 molal solution of sulfuric acid. Now let's calculate the mole fraction. The mole fraction of sulfuric acid is the number of moles of sulfuric acid divided by the total number of moles. Again, in the solution we have two sorts of molecules. We have water molecules and we have sulfuric acid molecules. So the total number of moles is the moles of sulfuric acid and the moles of water added together. So we have all that information down on the bottom of the screen. Let's plug it in. We have 1.35 moles of sulfuric acid. We have 2.09 moles of water, and that gives us a mole fraction of 0.392. That concludes this video. Please make sure to check back and see if there are other videos that will help you with calculations. And this is 00 Pi, your undercover chemist, signing out.